Hello students, welcome to the class of complex analysis. So today our topic is Rouche's theorem. So what is Rouche's theorem says? Suppose we have two meromorphic functions. Meromorphic functions means they are analytic except at their poles. Polesil ഒഴികെ ബാക്കി എല്ലായിടത്തും analytic ആവുന്ന function. So that functions are analytic except at poles. Okay, and which is defined in B closure of AR with the property that suppose it has no zeros or poles on the curve gamma, where gamma is a curve mod z minus a is equal to r. That means the boundary or the circle with the center a and radius r. Then on that gamma il matram, on that gamma this f and g have no poles and no zeros. Okay, then suppose these functions have the extra property that modulus of fz plus gz is strictly less than mod fz plus mod gz on gamma. Then the difference between number of zeros and poles of the function f will be equal to difference between number of zeros and poles of the function g. Okay, so which is the statement? So suppose we have a meromorphic, we have two meromorphic functions f and g, some region g, and with the property that I consider an open ball, okay, centered at a with the radius r, and assume that inside this region this f and g have no poles and no zeros inside this region. Then you consider a circle gamma, and which is the boundary of this neighborhood. Or you can, if this neighborhood is not in the shape of this one, then you consider the circle with the center a with the radius r, okay, this boundary. Then and assume then we have the property that modulus of fz plus gz, then you consider the sum of f and g and its modulus on the gamma. ഈ കർവിലൂടെ മാത്രമാണ് ഇതിൻ്റെ വാല്യൂ കൺസിഡർ ചെയ്യേണ്ടുള്ളൂ on this gamma, and if it satisfies the condition which is strictly less than mod fz plus mod gz, then it's this equation will be true for the functions f and g. Okay, and you know that every meromorphic function is analytic function. Every analytic functions are meromorphic functions, right? So this result can be used for analytic functions also. So we know that when if you have an analytic function, they have no poles. So pf and pg will be equal to 0, right? Therefore zeros of f will be equal to zeros of g, that you will get from the Rouche's theorem. So zeros of f is equal to 0 of g, zeros of number of zeros of g inside the same region bounded by this gamma. Okay, so let us assume this condition, modulus of fz plus gz is strictly less than this inequality. Okay, so assume modulus of fz plus gz is strictly less than mod fz plus mod gz on the curve gamma, on gamma, where gamma is a circle with a center a and radius r. Okay, ready? Then assume the condition if, okay, if this is true, what we can write is modulus of, when you divide by fz, when you divide by gz, we get fz divided by gz plus 1 will be strictly less than modulus of fz divided by gz plus 1. Okay, now assume the condition if possible fz divided by gz is non-negative, is non-negative, that means greater than or equal to 0, it is not negative. So when this quotient is positive always, this modulus can be omitted from this inequality. So what you get, fz divided by gz plus 1 is strictly less than fz divided by gz plus 1. Is it possible? No, which is always equal to, not the strict inequality, therefore which is not possible, which is absurd result, which is not possible. Therefore we can't assume fz by gz is greater than or equal to 0 or non-negative real number, non-negative real number. Therefore fz by gz will not assume the non-negative real number on gamma, which means that fz by gz will not assume a non-negative real number on gamma. So on gamma, fz by gz must be less than 0. Okay, So what you can write is fz by gz, positive real number, okay, positive real number. Then fz by gz, okay, will be belongs to always belongs to the complex number minus 0 comma interval 0 comma infinity, because if it is not non-negative real number, it will be a positive number always. It is not a non-negative real number means it is a negative real number, so it can't be belongs to 0 infinity in the interval 0 infinity. Therefore it can be considered c minus 0 infinity. Okay, so which means that fz by gz is a function which is defined from omega to c minus 0 comma infinity. So since f and g are meromorphic functions, f by g is also meromorphic. Since f and g are meromorphic, f by g is meromorphic. So it is a meromorphic function in this domain omega. Okay. Therefore, we can consider the branch of logarithm of the function. Consider logarithm L of fz by gz. Okay. Then what is L? L is the branch of logarithm. Where L is the branch of logarithm. Branch of logarithm on omega. Then L of fz by gz must be well defined. Okay, and what is the derivative of this function? Then derivative logarithm L of fz by gz divided fz divided by gz whole dash, derivative will be equal to, what we can write is L, derivative of logarithm is 1 by z, ln z is 1 by z, so 1 by fz by gz product derivative of f dash z by g dash z. So that is by quotient rule we can write fz by gz derivative. So this can be written fz by gz dash whole divided by fz by gz. So it is the derivative of d by dz of L of fz by gz. So which means that this function has a derivative. So what it means that this function has the primitive. So which means L of fz by gz is primitive for this can be written fz into fz by gz derivative 1 by fz gz. This can be written fz by gz inverse in a neighborhood of gamma. Okay. Now consider integral over gamma fz divided by gz derivative whole divided by fz divided by gz. Okay, this function. So this can be written integral over gamma. Instead of this function I can write derivative d by dz of d by dz of L of fz divided by gz dz. So here by fundamental theorem we get which is 0. Okay, so we get integral over gamma d by dz of the analytic function is 0 because we know that gz and fz has no zeros inside gamma. Therefore gz will be analytic in the region defined by gamma, and therefore branch of logarithm of analytic function will be again analytic, and derivative of analytic function will be always analytic, right? Therefore what you get is integral over a closed curve, rectifiable curve gamma, analytic function dz. Therefore by Cauchy's theorem we can say which is equal to 0. Okay, therefore we get integral over gamma. What is fz divided by gz dash divided by fz by gz, and this dash denotes the first derivative. Okay, so what is first derivative of a quotient? By quotient rule we can find out that 1 by fz dz is there. Okay, Then by quotient rule we can write it as denominator derivative of numerator minus numerator derivative of denominator whole divided by denominator the square, dz equal to 0. So that is integral over gamma. This can be simplify as gz will be cancelled, f dash z divided by fz will be there. Yes, gz will be cancelled and one gz, this gz will be cancelled. So first term will be f dash z divided by fz. Second term will be fz will be cancelled. This one gz will be cancelled. We get g dash divided by gz, dz equal to 0. So which means that integral over gamma f dash z divided by fz dz is equal to integral over gamma g dash z divided by gz dz. Okay. Now multiply by 1 by 2 pi I. So 1 by 2 pi I integral over gamma f dash z by fz dz equal to 1 by 2 pi I integral over gamma g dash z divided by gz dz. Okay. Now what is f and g? F and g are meromorphic functions. So when f and g are meromorphic functions, then by argument principle we have 1 by 2 pi I integral over gamma f dash z by fz dz is equal to, by argument principle, this is nothing but sigma k equal to 1 to n gamma set k minus sigma j equal to 1 to m n gamma pj will be equal to, here this for again by argument principle, sigma k equal to 1 to n gamma set k minus sigma j equal to 1 to m n gamma pj. And note that these set k, I will write here some set k prime and pj prime. Okay, here set k is the 0 of f set in that region, and set k, here pj is the pole of f set, and here set k prime is the 0 of gz, and pj prime is the pole of gz. Okay, then which means that number of zeros or zeros minus number of zeros, this is nothing but number of zeros. Okay, because since gamma is a circle, the index number n gamma z will be equal to 1 for every z inside that region, inside gamma. Okay, therefore each index will be equal to 1. So which means that this summation minus this summation is nothing but number of 0 of f minus number of 0 of pj poles. So which means a ZF minus PF equal to ZG minus PG by the notation. So we proved the Rouche's theorem. When f and g are meromorphic function, and suppose mod fz is less than, mod fz plus gz is strictly less than mod fz plus mod gz on gamma, note that on gamma, then zeros of f minus poles of f will be equal to zeros of g minus poles of g. Okay, this is called a Rouche's theorem. Okay, and using this one we can prove one more result which is based on Rouche's theorem, and I can say that which is the second version of Rouche's theorem. Rouche's theorem, which says that suppose f and g are analytic function, because analytic functions are meromorphic functions, right? Suppose f and g are analytic functions in an open set G, containing the closure of the neighborhood B closure AR. Let gamma be the circle, same circle, gamma be a circle defined by mod z minus a equal to R, and if mod fz plus gz is strictly less than mod gz on gamma, then f and g have same number of zeros inside gamma, same number of zeros inside gamma, because when a function is analytic it has no poles, right? Since it has no poles, pf and pg will be equal to 0. Therefore by Rouche's theorem we can say that zeros of f is equal to zeros of g. Okay, I will prove this result. Proof. And we have given that mod fz plus mod gz will be strictly less than mod gz on gamma. Then as above, fz by gz will be plus 1 is strictly less than modulus of gz by gz will be 1, okay? 1 on gamma. Okay, now take, let us set this an element in gamma. When z is an element in gamma, what will be fz by gz? The distance between fz by gz, comma minus 1. The distance between them will be, I can say, which is strictly less than 1. Because fz by gz plus 1 is less than 1 on gamma means fz by gz and minus 1. The distance between, this can be written fz by gz minus 1, right? So fz by gz comma minus 1, the distance between them is less than 1. This is the meaning of this statement. Okay, therefore we can write, which implies, if we take z in gamma, then z satisfies the result that fz divided by gz comma minus 1, the distance between the modulus of fz plus 1, fz by gz plus 1 means fz by gz minus 1 is strictly less than 1. Okay. Now take, let sigma equal to f composition gamma. Now take sigma equal to f composition gamma, where this capital F is defined by fz by gz, f by g. Now I take sigma equal to f composition gamma. Since gamma is a curve and f is a function f by g, okay, since f, okay, then sigma will be a closed curve. So if you define sigma is equal to f by g composition gamma, then sigma is a closed curve, closed rectifiable curve. And what is n sigma 0, the center point n comma 0, n sigma 0? That is by definition, we know that what is n gamma a? N gamma a equal to 1 by 2 pi a integral over gamma 1 by z minus a dz. So by using this definition, what is n gamma 0? Sorry, n sigma 0? N sigma 0 will be 1 by 2 pi I integral over sigma 1 by some w minus 0 dw. Okay, so what is this? Which is equal to 1 by 2 pi I integral over sigma 1 by w dw. So which is equal to 0, because the center point is 0 is always belongs to the outside of, always lies outside of sigma. But n comma 0 also can be written 1 by 2 pi I integral over gamma capital F dash z divided by capital F z dz. Okay, so which will be equal to 1 by 2 pi I integral over gamma, capital F is f by g dash divided by f by g dz. So which will be equal to 1 by 2 pi I integral over gamma. This is already we derived that f dash z divided by sz minus g dash z divided by gz dz. Okay, so that can be splitted. So what is this value is actually 0. 0 will be equal to 1 by 2 pi I integral over this gamma capital small f dash z divided by fz dz minus 1 by 2 pi I integral over gamma g dash z divided by gz dz. And this is equal to, what is this? By argument principle, this is equal to the number of zeros of f inside gamma, and this is number of zeros of g inside gamma, because f and g are analytic function, they have no poles, right? Therefore this summation with respect to the poles can be neglected. So what you get is, this will be equal to number of zeros of f minus number of zeros of g inside gamma. Okay, I will write inside gamma. So which means that number of zero of f is equal to number of zero of g inside gamma. So when f and g are analytic function and it has the property that mod f z plus mod g z, modulus of f z plus g z is strictly less than mod g z on gamma, then we can prove that number of zeros of f inside gamma equal to number of zeros of g inside gamma. Okay, and as a note again I would like to say this theorem or this statement can be also applied for if f and g are analytic with the property modulus of fz minus gz is strictly less than mod gz. That means this result can be applied for analytic function which has this property. Okay. Now this Rouche's theorem can also use for proving fundamental theorem. So what is fundamental theorem of algebra? Fundamental theorem for algebra. So which says that if Pz is a non-constant polynomial, then Pz has at least one zero. In C. So which is the statement of fundamental theorem, right? So how will you prove this statement by using Rouche's theorem? So for the proof, let Pz is a non-constant polynomial, then we can write it as some a0 plus a1 z plus a2 z square plus etc plus some an z raised to n. Assume that the degree of the polynomial is n, comma n is greater than or equal to 1. Then only it is a non-constant polynomial. Okay. Then what will be Pz divided by z raised to n? That will be of the form a0 divided by z raised to n, a1 divided by z raised to n minus 1, a2 divided by z raised to n minus 2, etc. plus some an minus 1 divided by z. Okay, z divided by an plus an. Now for the convenience I choose the coefficient of z raised to n equal to 1. Okay, then what will happen? Pz, now assume the coefficient of z and an equal to 1. Then Pz by z raised to n can be written a0 by z raised to n plus a1 by z raised to n minus 1 plus etc plus an minus 1 by z plus 1. This an is taken as 1. Okay, so therefore Pz divided by z raised to n minus 1 can be written a0 by z raised to n plus a1 by z raised to n minus 1 plus etc plus an minus 1 by z. Okay. Now what will happen when z tends to infinity of this term? Consider this right side term. So what will happen when z tends to infinity? These coefficients a0 by z raised to n plus a1 by z raised to n minus 1 plus etc plus an minus 1 by z. Since all these elements have z in the denominator, it will goes to 0. So limit of this term goes to 0 means there exists some r greater than 0 such that we can choose some r greater than 0 such that modulus of a0 by z raised to n plus a1 by z raised to n minus 1 plus etc plus an minus 1 by z is strictly less than 1 for every mod z greater than or equal to r. We can choose such kind of r. Yeah, because it is tends to 0 and there are some terms which are strictly less than 1 for these terms, for this function. So I will consider such set with this property. So which means that what is this? This is nothing but Pz divided by z raised to n minus 1. So this can be written Pz divided by z raised to n minus 1 is less than 1 for every set such that mod z is greater than or equal to r. So which means that modulus of Pz minus z raised to n is less than mod z raised to n on the curve mod z equal to r. Right? Okay. So now we have what is Pz? A polynomial of degree n. Therefore, polynomials are analytic function. Therefore, Pz is analytic. And z raised to n is a nth degree polynomial which is also analytic. Here also z raised to n is okay. So this is Pz. Pz is some fz and this is some gz. So fz minus gz have the property that modulus of fz minus gz is strictly less than mod gz. Also P and here Pz and Z raised to n are analytic functions. Analytic functions. Therefore, by the second version of Rouche's theorem, what we can say is number of zeros of Pz inside R will be equal to inside the gamma, where gamma is the mod z equal to R. Okay, so inside the region bounded by gamma, I choose this as some gamma. So by second version or the weaker version of Rouche's theorem, I can write number of zeros of Pz will be equal to number of zeros of Gz, where Gz is z raised to n inside gamma, but gamma is mod z equal to R. Okay, so number of zeros of, and how many zeros of z raised to n exist in mod z equal to R, inside mod z equal to R. So that is, since z raised to n is a polynomial of nth degree, it has n zeros inside gamma. Therefore, Pz also has zeros inside gamma, which implies Pz has 0 inside gamma, or in particular it has 1 0. Therefore, by fundamental theorem, it is true. That means fundamental theorem can also be proved by using Rouche's theorem.